Okay, so today we're going to kind of review all the fraction rules and try to simplify everything and kind of get some ideas of this. So the first thing is, this is called a mixed fraction. Really what it's saying is you have 3 and 2/7. So if you want to picture this visually, you have like 3 whole pies and then like 2 out of 7 pieces of a pie. If I could break this up into 5 more pieces, so 1, 2, 3, 4, 5. Yeah, so you have these 2/7 out of it. I didn't draw that very well, but that's what we kind of have. Unfortunately, when you're talking about whole things and you're talking about pieces, it kind of gets confusing. So generally, we don't like to write these as mixed numbers. Generally, we like to write these things as improper fractions. So an improper fraction is a single fraction with no number in front. And so how we change this into an improper fraction is we think about how many pieces we really have with those 3. Well, if you have 3 whole things and they're broken up into 7 pieces, from this 3 you'd get 21, because 3 times 7 is 21. And we already had 2 more pieces on top, so that would be 23/7. So how you change a mixed number into an improper fraction is you take your whole things, divide it, figure out how many you have by multiplying those 2 things together, and then add it to your top, because that's how many total pieces you have. So instead of thinking of whole things, it's your number of pieces on top and how you're breaking it up on bottom. Okay. So we'll do one more example of that. If I have 2 and 3/5, well, if I want to change this into an improper fraction, we'd have 2 times 5, which is 10, plus 3 is 13. So that'd be 13/5. So that's my improper fraction. Let's try a couple other things with fractions. First, let's multiply fractions. To do any operation with fractions, you can't have them as as mixed numbers. So we're going to change them into improper fractions. That'd be 7/3, because 2 times 3 is 6, plus 1 is 7. And this would be 16/5, because 3 times 5 is 15, plus 1 is 16. How you end up multiplying fractions is you multiply the top numbers and you multiply the bottom numbers. That is going to end up giving us, and I have no clue what 7 times 16 is, so I'm going to take a calculator. That'd be 112 over 15. And this would be my final answer. Let's try another one. Okay, we're going to try to divide these 2 numbers. First thing is, I want to change them both to improper fractions. So this would be 17/3, because 5 times 3 is 15, plus 2 is 17. And this, it's not a fraction, so we have to make it a fraction. If you have a whole number, you can make anything a fraction by putting it over 1. So now we have 17/3 and divided by 6/1. Well, when you divide fractions, we really don't have the same kind of operation for dividing. What you do for dividing fractions is you change the division into multiplication, and you take the inverse of the fraction, or you flip it over, making it 1/6. From here, now since it's multiplication again, we would just multiply straight across. And once we multiply straight across, we would have 17/18, which would be my final answer. So on multiplying fractions again, or dividing fractions, just like multiplying fractions, we want to make them improper, and then once we make them improper fractions, we can do the operation. Let's try another example. Okay, so I've already moved these to improper fractions, but I want to show you a neat trick that could happen. So, with multiplication, you actually can reduce fractions before you start. Like normally, you can try to reduce these fractions like this. Like you could go, okay, is there anything that divides 15 and 7? The answer to that is no. And you could go, okay, is there anything that can divide 14 and 3? Well, the answer to that is no. But in multiplication, you get an extra special operation. And here's the reason why. 7 times 3 is the same as 3 times 7. They're both 21. So because these things are actually the same, I can change up the fractions to fit how I want them to fit. So I could really make this 15 over 3 times 14 over 7. Because 7 times 3 is 21, or 3 times 7 is 21. Well, the reason that is useful is what's 15 divided by 3? Oh, that's 5. What's 14 divided by 7? Oh, that's 2. So that gives me 10. Really, this process that we do is called cross-reducing. So if anything can be reduced on the diagonals, you can reduce them on the diagonals and then just multiply across. So a lot of times when they say they want it in simplest form, cross-reducing helps you put in simplest form the fastest. We're going to do 2 quick more examples where we do one with adding and then one with subtracting. Okay, so we have to add 3 1/5 plus 2 4/7. Again, the first thing I would do every single time is change these to improper fractions. It's going to make it easier in the long run. So we're going to get this to be 16 over 5 plus 18 over 7. Now at this step, what we'd want to do is we'd want to add these things together. Now where multiplication and division are a little bit easier because you can just multiply straight across, adding and division, adding and subtracting, you need the same piece sizes. Like I can't add 5 and 7 because they're different sizes and it doesn't work out for our adding the number of pieces. So what we need to do is we need to get these the same size. So to do that, I'm going to times this side by 7, and I'm going to times this side by 5 to make sure that they are the same size. This would end up giving us, I'm going to take my calculator over here to help me, 16 times 7 is 112, and 18 times 5 is 90. So that's going to be 112 over 35, and that's going to be 90 over 35. Now I would add these two things together, which would give me 202 over 35. And you'll notice I didn't add these together because we're just counting up how many total pieces we have. So this, I think, would be our final answer. You always want to check to see if you can reduce it. So you could try to divide it that way, which it didn't reduce. And then you think, well, what can divide 35? Well, 7 and 5 could. Well, 5's not going to divide 202, and I don't think 7 will either. Nope. So there's nothing to reduce it. That would be your final answer. Let's try one last one. Again, what I would do for your first step is make these improper fractions, which this would be 7 over 4, and this would be 17 over 3. Now again, we can't subtract these because they aren't like sizes. So to make that happen, we're going to times this side by 3, and we're going to times this side by 4. And what that's going to give us is, is 21 over 12 minus 28 over 12. Or, that's not 28. Hold up. 17 times 4 is a bigger number than that. 68. So that's going to be 68 over 12, which would give us a grand total of negative 47 over 12, and that would be our final answer. So again, when you do any of these types of problems, the biggest thing that you want to do is you want to make sure that you have the same size. So to do that, I'm going to times this side by 3, and I'm going to times this side by 4. And what's that's going to give us is, is 21 over 12 minus 28 over 12. So again, when you do any of these types of problems, the biggest thing that you want to do is first get it into an improper fraction, and then once it's an improper fraction, you want to use the different rules. Multiplication, the nice part, is straight across, then top of bottom. Division, we change to multiplication and we flip the second fraction. And then adding and subtracting, you need the denominators to be the same. So we need the same denominators. Okay, so just make sure that you're trying the different things. If you get stuck, just let me know.